All right, there are many materials that are available for use in these processes, and the selection of the proper one is dependent on the end-use application of the part. Most materials are intended to mimic a specific property of a common commodity or engineering thermoplastic as best as possible. Here's a sample keychain showing the materials that we use in our processes, and I'll explain the key attributes of each, organized by technology and stiffness. First one, this is Somos 9120. This is our most flexible stereolithography material. It's similar in stiffness to a polypropylene material, and it's fairly durable as well. It's translucent amber in color. This bar, like many that you'll see here, was finished with our standard matte texture that looks like frosted glass. Next up, Accura 25 is a polypropylene mimic material also that we use in our largest stereolithography machines, the iPro 9000. It's also quite resistant to picking up moisture. Its stiffness allows it to mimic common grades of ABS. Accura 60 is another clear, colorless material that's slightly stiffer, yet still durable. It mimics some grades of polycarbonate. It is known for very high resolution detail reproduction. Prototherm is a high temperature material that is transparent red. Its stiffness is slightly greater than a polycarbonate and can be used successfully at temperatures as high as boiling water or slightly greater. Nanotool is our stiffest stereolithography material and is highly filled with ceramic. It is similar to a liquid crystal polymer in stiffness and very resistant to temperatures, even as high as 250 C. It also forms the backbone for our SL Armor product, which is plated with nickel to give extreme stiffness and strength. For our SLS process, we offer Duraform EX Black. EX Black is in fact nylon 11 and inherits its properties. It has a slightly rough surface texture, but is otherwise extremely tough and rugged. It can take on environmental abuse far better than even the best SL materials. Finally, our Envision HR 3D printers use 3D Systems HR 200 material. It's similar in stiffness to a polypropylene, but not as tough or durable as the stereolithography materials. It is translucent blue in color and is used for very high resolution parts. Here is a look inside as the process of stereolithography is working. Three-dimensional geometry of the desired parts is fed to the computer controlling the process. The computer takes that geometry and sends it to a laser scanning system as a series of two-dimensional cross-sections. The laser is then used to draw the 2D cross-sections of the part, or in this case a number of parts, on the surface of a liquid, seen here in the process vat. Wherever the laser touches the liquid, it chemically reacts and turns it to a solid. Once a 2D section is complete, a platform holding the parts beneath the liquid surface indexes downward by a few thousandths of an inch to make room for the next cross-section, and a recoater passes over the freshly imaged surface to apply resin for the next layer. Then the process repeats for the subsequent cross-sections until the full height of the build is reached. When the build is complete, the platform raises out of the liquid and the solid parts are ready to remove from the process. This same process of imaging 2D cross-sections is at the core of all the technologies that we use here at Fineline. For selective laser sintering, the working medium is a powder bed rather than a liquid surface. And for 3D printing, the cross-sections are jetted out of an inkjet printhead onto a build platform.